All right, we're going to look at what we call nth roots, which just means we're considering the common square root, but then expanding on that to include any possible index, where instead of just a squared, we're looking at the results of a to some other power than n. Okay, so let's just start with just a square root. We use square root so commonly that we don't put the number there anymore, but there is an understood 2 here. That's called the index of the radical, and that tells us what it is that we're looking for. So this is asking me to find whatever it is that when I square it, it equals 49 z to the 8th. So I need something times itself to equal 49z to the 8th. Okay, well, I can also think about this as the square root of 49 times the square root of z to the 8th. And here it starts to be a little bit easier to think about. I know 49 is 7 squared. And then I want to think about what can I do to z so that when I square it, I'm going to get 8. Well, 4 times 2 is 8. I can use that. Now, because squaring and square root are inverse operations, the square root of 7 squared I know is just 7, and the square root of this squared is just that, z to the 4th. Works out really nicely when what's in there is a perfect square, but consider something like 98 z to the 9th. If I want to try to take the square root of that, well, I'm still going to break it apart. Square root of 98 times the square root of z to the 9th. And we're remembering our index is 2. 98 is not a perfect square. If I try to take the square root, I'm going to get some irrational decimal. But I do know that 49 times 7 will give me 98. Because I was taking the square root of 98, I am looking for perfect squares that I can divide out. Same thing's going to go here. When it was 8, I just divide that by 2 and I get 4. Well, if I divide 9 by 2, I'm going to get some kind of remainder. So I've got the square root. I can do z to the 4th, z to the 4th, and another z to the 1st. So I'm going to split those up. Square root of z to the 4th squared and the square root of z. Square root of 7 square root. I'm going to write that as 7 squared. So square root of 7 squared is just 7. Square root of z to the 4th squared is z to the 4th. I cleared those out. I want to put those out front together. And then I'm going to leave everything that was inside. Okay? Take some practice and we'll mess with it in school or in class. So now let's look when we've changed the index. So now I'm taking the cube root. So this just says what times itself 3 times gives me this answer. And this negative out front is important. It's just going to stay there. And so I'm taking the cube root, some power of 2a minus 1. It doesn't even matter what that is. I'm going to raise that to some power and cube it, and I need it to equal 6. Well, 2 times 3 is 6. So now I've got the cube root of a cube. And I'm left with 2a minus 1 squared. And I don't want to forget about this negative. It should come down with it. Okay. Lots of simplifying in class we're going to practice. Sometimes you just can't do anything about it, right? And even this square root of 7 that we ended up with in here. There is no perfect square I can divide out of that to make that any smaller. That's as low as it can go. Square root of 2, square root of 3. There is no perfect square we can divide out of that, so we just have to leave it alone. Okay? Sometimes we're going to need an estimate. Sometimes we're going to need a decimal. And your calculator will do not only square roots, but nth roots. And here's how you find it. When you get your calculator on, we're gonna hit math. And then see option number 5, where it says the xth root. When we select that, it gives us a little box in the index position, and then our other box to fill in for what we're taking the radical of. So in this case, we want the 5th root of 18.2. So 5, and then make sure you arrow where you are, 18.2. Hit enter. And we want it to 3 decimal places, so 1.786. That's where it ends. But when I roll over and check the 5, it would be fair to round that up, 1.787. So approximately 1.787. That's it. We're going to do a lot of practice in class, but this will get you through it.